was easier. Only this is little bit difficult for you. Okay, why the point is here? Why the projection of why the top view of a point C is over here? Why not below or not above over here like other projections? There's one more concept. I explained it to you. Okay, as I explained this. So in this case, a point is in front of VP and above HP or behind VP or below HP. Now there is one more case wherein a point will be on one of the planes, either it will be on vertical plane or horizontal plane. In such cases, a point will lie in two quadrants simultaneously. Okay, two quadrants simultaneously. How is it? How is it that? Let me just explain it to you using the same figure. Yeah. Let me get all this. Yeah. So there is one more concept. Let me take a pen. Let me just draw a vertical plane and a horizontal plane in 2D fashion. So this is your horizontal plane. Okay, this is your vertical plane. So here in this case, a point is above HP in front of VP. So here with respect to second quadrant, a point is above HP behind VP. Here with respect to third quadrant, a point is below HP and behind VP. So with respect to fourth quadrant, it is below HP and in front of VP. So this is one case wherein a point lies in its individual quadrants. There is one more case wherein a point lies in two quadrants simultaneously. What is that? Let me try here once again. So this is your horizontal plane. So this is your vertical plane. Okay. Now, case number one. Okay. Let me just place a point here on a vertical plane, here on a horizontal plane, here also on a horizontal plane, here also on horizontal plane. Okay? Just listen to me. Okay. Let me call this point as A. Let me call this point as B. Let me call this point as C. And let me call this point as D. So this is your first quadrant. This is your second quadrant. This is your second quadrant. So this is your third quadrant, and this is your fourth quadrant, depending on the observer here who is standing here. Okay. Now let me first consider point A. Okay. So in this point, so what will be the sentence is a point is on HP. A point is instead of above, it will be on HP. If a point is on HP and in front of VP, it means a point that is over here. Okay, that is over here. That is on horizontal plane. It is on HP and it is in front of vertical plane. It means a point lies both in first quadrant and as well as in fourth quadrant. Okay, as well as in fourth quadrant. Now, what about the views? How will you draw the views of this? How will you draw the front view and top view of this? A point which is on HP and in front of uh, vertical plane. Let me call this as point A. Okay. Let me draw the projection of this point A. Okay. Let me draw X and Y. Okay. Now, where is the front view of this point? Where is the front view of this point? So, you know, the front view of a point always falls on vertical plane. Okay. Now, since it is on horizontal plane, the point itself lies in the horizontal plane. Neither it is above nor it is in front. Okay. It is not in the space. It is lying on the horizontal plane. A point is lying on the horizontal plane. It means the object is placed on horizontal plane. Okay. Object is placed on horizontal plane. So where is the front view of this point? Can you tell me? Where will be the front view of this point? The front view of the point will be exactly on this reference line XY in such case. So when a point lies in first quadrant as well as in fourth quadrant, okay, your front view of a point, that is A, will be on XY line. Okay, on XY line, that is A dash. Now where is the top view? Where is the top view? Now, with respect to both the first quadrant and fourth quadrant, you are rotating this plane in clockwise direction. What is the top view? Let it be any distance. Okay, so top view will be below. Okay, at some distance which is given to you. So it is here, and denoted by E. Okay, so whenever a point is on HP, that is over here. Okay, and in front of vertical plane. So this is how your front view will be on XY line, and top view will be below XY line when a point is on HP and in front of vertical plane. That is your first case. Okay, first quadrant, a point will be lying in both first and fourth quadrant. That is your first case. Okay, a point lies in both first and fourth quadrant. It means whenever a question is given to you, a point is on HP and some that is 30 in front of VP, to identify the quadrant in which it lies. It means your point lies in both first as well as fourth quadrant. Okay, first as well as fourth quadrant. That is this as well as this. Okay, so this is the first case. Okay, understood the first case? Understood. When a point is on, understood? Understood. Okay, put a message in the chat box, or else you can just give a reply. Understood?
So explain the top view.
Okay, top view, if a point is here, okay, a point is here, right, on horizontal plane. Okay, so where is the front view? It will just exactly fall on this one. Your front view is here, again, which is denoted by A dash. Where is your top view? It is on horizontal plane. Now, with respect to first quadrant and fourth quadrant, where is your horizontal plane? Is it below XY line or above XY line? You're rotating this plane, right?
Below XY line.
Below XY line, right? So, what about this top view? Will it go below? Will it go below? So that's what I have drawn here. Below XY line. Okay. Distance will be given to you. Okay. This distance will be given to you. Got it now?
Yes, sir.
Okay. So this is with respect to point A. Okay. This, it lies in first as well as fourth quadrant. Now, when a point, let me consider point B now. Okay. On vertical plane and above horizontal plane. Okay. Then let me this one. Second case, above horizontal plane and on vertical plane. That is here. Point is somewhere here. Okay, a point is somewhere here. Let me erase all other. Okay, forward. Vertical plane, horizontal plane. Okay, your point. First quadrant, second quadrant, third quadrant, and fourth quadrant. Position of the observer. Okay, now we are done with this point A. Now we'll move on to point B. So it is above horizontal plane. You can clearly see here it is above horizontal plane and on vertical plane. Okay, it is above horizontal plane and on vertical plane. So if a question is given, a point is above on vertical plane and above horizontal plane, it means a point lies in first as well as second quadrant. First as well as second quadrant. Let me draw the views of it. So let me draw the reference line X and Y. Okay. So where is the front view? Is it above XY line? So this is your XY line. Is it above XY line? So it is above XY line. Okay, above XY line denoted by B dash. Okay, denoted by B dash. So where is the top view? What is the top view? What is the top view? When you see it from here, you see the object from here. Where is the top view? Will it fall exactly on this? Will it fall exactly on the XY line? Is it right? The top view is here. So which is denoted by B. So this is with respect to second case. Okay, a point will be both in first and second quadrant when it is above HP and on vertical plane. So these are its projection. Front view will be above XY line and top view will be on XY line. Okay, getting it? Clear? Is it clear? Yeah, fine. Now let's move on to the next point, that is point C. Okay, so point C, let me just change the color. Okay, so point C is here, that is on horizontal plane. Okay, on horizontal plane. Let me just check off this. This is on horizontal plane and below, behind vertical plane. On horizontal plane and behind vertical plane. So on horizontal plane and behind vertical plane. So if it is on horizontal plane and behind vertical plane, a point lies in second as well as third quadrant. Second as well as third quadrant. Let me draw the front projection of it. First, draw the reference line X and Y. Here, draw the reference line X and Y. So where is the front view? Front view, will it exactly fall on this? Will it exactly fall on XY line? It will fall on XY line. So let me denote it by C dash. Okay, C dash. Now where is your top view? Where is the top view? How are you rotating this plane? How are you rotating this plane? You're rotating this plane in clockwise direction. Your horizontal plane will go up. So your top view will be here. Your top view will be here. So this is denoted by C. Okay, this is denoted by C. Just remember here, with respect to third quadrant, where is your horizontal plane? It is above, right? It is above. Even with respect to second quadrant, your horizontal plane is above. So your top view will come above XY line. Now, since your point is on horizontal plane, your front view will fall on XY line. It means it is both on second quadrant and third quadrant. Understood? So this is with respect to third case. Okay, point C. Got it? Got it? Yes? Yes. You can either put a message or you can answer me.
Yes, sir.
Okay, fine. Now, the last case, that is a point on vertical plane and below horizontal plane. So here, let me just type up this. It is on vertical plane and below horizontal plane. So if it is on vertical plane and below horizontal plane, it means a point lies in third and fourth quadrant. Third and fourth quadrant. Third and fourth quadrant. Okay. Now let us draw the front view of it. So where is the front view? First, let me draw the reference line X and Y. Let me just draw reference line X and Y. Okay. So where is the top front view? Where is the front view? Is it below XY line? Is it below XY line? So front view is below XY line. Okay. Let me just denote it by D. So it is here denoted by D dash. Okay. Now where is your top view? Where is your top view? So the top view will fall on XY line. Top view. When you see it from here, where is it? It is on XY line. Your top view is here. Your top view is here denoted by D. Okay. So this is with respect to the fourth case, that is on vertical plane and below horizontal plane. In the first case, that is here, your front view A dash will be here and your top view, okay, top view will be below, that is A here. Okay, this is first case. In this first case, a point lies in first as well as fourth quadrant. In the second case, when a point is here, it lies in first and second quadrant. Third case, when a point is on horizontal plane behind vertical plane, a point is in second and third quadrant. And when it is on vertical plane below horizontal plane, a point is in third and third quadrant. And these are its respective projections. This is first case, this is second case, this is third case, and this is fourth case. Got it? Got it, everyone? Fourth case, let me explain it once again. A point is here on vertical plane. Okay, a point is on vertical plane and below horizontal plane. It is below horizontal plane. Okay, so it means a point lies in third as well as fourth quadrant. Okay, a point lies in both third as well as fourth quadrant. So when you draw the views projections, where is your front view? Is it below? It is below, which is here, denoted by D dash. Where is your top view? It is here. But when you see the top view, where it will fall? Will it fall on XY line, which is drawn here, which is denoted by D. Got it now? Got it now? Yeah, fine. Okay. Let me just move on to the problem now, which I gave you. This problem we did in the last class. This was the homework problem which was given to you. Okay. Draw the projections of the following points on the same XY line. On the same XY line, it has to be drawn on the same XY line, keeping convenient distance between each projection. When you draw the projection on the same XY line, there should be a convenient distance between projection of A, projection of point B, C, and D. Okay. Name the quadrants in which they lie. Depending on the sentence which is given to you, you have to identify in which quadrant a point lies. Okay. So first point A is 30 mm above HP and 35 mm in front of VP. So 30 mm above HP means your front view is above, top view is below at a distance of 30 mm. Front view is at a distance of 30 mm above XY line and top view is at a distance of 35 mm below XY line. If I draw it in 3D, this is how it is. So this is your first quadrant. It lies in the first quadrant, right? Above HP and in front of EP, a point lies in the first quadrant. So the point is here, somewhere here, which is 30 mm. This is 30 mm, which is given to you. And this is 35. This is 35. So front view is above XY line, okay, which is at a distance 30 mm above XY line, which is drawn here. And top view is on horizontal plane, which is at a distance 35 mm. We have to rotate this plane, this distance will come down. So that is what is drawn here, front view and top view. So this is your first projection of point A. Okay, now next projection of point B. A point is above HP and 40 mm behind VP. In which quadrant the point B lies? In which quadrant the point B lies? In which quadrant a point B lies? Point B above HP. Above HP, let me just draw it. Okay, above HP behind VP. This is above HP behind VP. A point is in the second quadrant. Okay, point is in the second quadrant. Above HP, this is 35. This is 35 and 40 mm behind VP, and this is 40. This is 40. Okay, this is point B. Front view is on vertical plane B dash, and top view is B. Okay. Where is the front view and at what distance? It is above XY line, which is 35. So B dash. Okay, B dash. And where is your top view? Top view also, when you rotate this plane in clockwise direction, it will also come above XY line with respect to second quadrant, which is at the distance of 40 mm. This is 40 mm, parallel to this. Okay, parallel to this line. This line. So this, when you rotate it, it will come above. So 40 mm. So over here. So this is B. Okay, this is B. This is with respect to projection of point B. Now a projection of point C. Projection of point C above HP and on vertical plane. A point lies in which quadrant? Can you tell me this? Just now I explained it to you. And a point is above HP and on vertical plane. In which quadrant does a point lie? Just now I explained it, right? And a point is above HP and on vertical plane. A point lies in which quadrant? Yes? Above HP, right? Above HP at a distance of 40 mm. Okay? And on vertical plane. On vertical plane. A point lies in which quadrant? Can you put a message
First
in?
and second.
Yeah, first and second quadrant. First and second quadrant. Okay. Now have you draw the views? Where is the front view? Is it above XY line? At what distance? You can see here. Front view is above XY line at a distance of 40 mm. A distance of 40 mm. Now where is your top view? When you see it from top, where will this fall? This top view will fall on your reference line XY. Okay, which is drawn here, point C. Okay, C dash and C, front view and top view. Okay, this is your projection of point C. Okay, this is how it is done. Got it now? Got it? Got it? Got it? The same thing which we did, okay, just now, before this. Now with respect to the last one, point D, can you tell me a point D lies in which quadrant? Below HP, in front of BP? I'll not draw anything. You have to tell me in which quadrant a point D lies. Can you tell me in which quadrant a point D lies?
Fourth.
Yeah, fourth quadrant, because it is below HP and in front of below HP. That is below HP at what distance? 35 mm, and in front of BP, in front of BP at distance 30 mm. So where is your front view? Front view is at a distance of 35 mm below XY line. Okay, this distance, which is drawn here, denoted by D dash. Next, where is your top view? Again, you rotate this plane in clockwise direction. The top view also will be below with respect to fourth quadrant, which is at what distance? This distance. Okay, this distance will come down. This distance will come down, and that is a distance of 30 mm. Your top view, that is D. So these are your projections of point A, point B, point C, and point D on the same XY line. On the same XY line. Here you can write down, just write down with respect to first point A, BP and HP. With respect to point B, okay, both BP and HP are above. No need to write anything with respect to point D because it lies in first and second quadrant both. And here you can just write down both HP and BP are below with respect to fourth quadrant. Okay, with respect to fourth quadrant. Got it? Make sure one more thing which I forgot to tell you in the previous classes. Whenever you are writing this X and Y and BP and HP, when you are drawing This must be written in capital letters and this must be written in small letters. Okay, got it? So point A lies in first quadrant, point B lies in second quadrant, then point C lies in first as well as second quadrant, and point D lies in fourth quadrant. Okay, you have to write the answer because it is asked in the question. Name the quadrants in which they lie. Okay, point A first, point B second, point C first as well as second, point D fourth quadrant. And one more thing here, you are not without fail. You have to mention all dimensions are in mm. That has to be written. Okay, this has to be written at the right bottom corner because here you are not mentioning any. Here you are not indicating any units. Okay, so here at the right bottom corner you have to indicate that all dimensions are in mm. Okay? Then only your problem is complete. Got it? Now we'll move on to a problem to draw the side view of a point. Okay, using only first angle projections, we'll see that. Okay, how to VP and HP. So depending on the quadrant in which they lie, you can see here it's written here. Depending on the quadrant in which they lie, okay, you have to write vertical plane and horizontal plane. Okay, vertical plane and horizontal plane. You know, point A lies in first quadrant, so vertical plane is above XY line, and what horizontal plane is below XY line. Same with respect to point B. It lies in second quadrant. You know it. And with respect to second quadrant, both horizontal plane and vertical plane are above XY line, right? Above XY line. And with respect to this, no need to write anything because the point lies in both the quadrants. Okay, a point lies in both the quadrants. You are not supposed to write anything with respect to this point C. If it lies only in single quadrant, you have to indicate it. Okay, if a point lies in both the two quadrants simultaneously, you cannot write anything. Okay, don't write anything. It is written here, but you are not supposed to write it. Okay. Now, if you consider this, it lies in first and second quadrant. So here it is written VP above, horizontal plane below. But with respect to second quadrant, horizontal plane is above only. Okay, horizontal plane is above. But it's better you not write when the point lies in both quadrants. Okay, both quadrants. Now, point D lies in fourth quadrant. Your both horizontal plane and vertical plane are below XY line. Below XY line. Got it? Any doubts here? Now we'll move on to drawing the side view. Okay, fine. Let me just come out of this. Let me keep it. Just take down this question. Let me just change this. Same thing, only point A I've taken. Point A is 30 mm above HP and 20 mm in front of AP. Okay, they don't take down this. Draw the projections of a point. Projection of the point A 30 mm above HP and 20 mm in front of AP. Okay, draw all three projections. Okay, all three projections. It means you have to draw front view, you have to draw top view, you have to draw also side view. Side view, you can draw any side view. You can either draw right side view or left side view. Okay, left side view. Let me draw right side view. Let me draw right side view. Let me just shorten this line. Point is here. You can just draw it. I'll tell you how to draw the side view. So this you can easily draw it. Okay, let me just move these two here a little. This is 20. As I told you, we'll only consider the first quadrant. Okay, draw draw all the three projections of the following point, which is 30 mm above HP and 20 mm in front of vertical plane. 20 mm in front of vertical plane. So this is the front view and this is your top view. Let me just move this a little here. Okay, little here. Because I'll be drawing right side view. Right side view will fall on left profile plane. Right side view will fall on left profile plane. Let me just draw here, right here, X and Y. Let me just move this vertical plane here and horizontal plane over here. Okay. Now you can easily draw this. Now how will you draw the side view? How will you draw the side view? This you can easily draw. Front view and top view of a point A. Okay. Now how will you draw the side view? Where is the side view of a point with respect to first quadrant? Whether it is above XY line or below XY line. Whether it is above XY line or below XY line. Where is it? Where is it? Whether it is above XY line or below XY line. This is what I've given you, right? When we were learning the first quadrant. We were discussing the first quadrant. This is vertical plane. This is your horizontal plane. This is your left profile plane. This is your right profile plane. Okay. So here your front view. So here it is your top view. Okay. And left profile plane, right side view. And on right profile plane, left side view. I've told you we'll be drawing which view? We'll be drawing right side view, okay, which will fall on left profile plane. That is your side view will come. Let me just draw one more reference line as you have drawn here. Reference line X and Y. Okay, X and Y in the similar fashion. In order to draw the side view, you have to draw one more reference line, which is denoted by X1 and Y1, or it is also denoted by X dash capital. This is capital X dash or Y dash. Either you can write X1 Y1 or X dash Y dash. Okay, this is a reference line in order to draw the side view. So this line is called as X1 Y1 line. This line is called as X1 Y1 line. That is a reference line in order to draw the side view. Now I have told you there are two methods in order to draw the side view. So which are those two methods? One is Meter method, and the other one is arc method. Another one is arc method. We'll draw the same problem, okay, using both these methods, meter method and arc method. Okay. So what is meter method? First you have to draw this, okay, front view and top view. So make sure whenever you draw the front view and top view, better draw it in the center. Okay, you should be knowing where you will be drawing your side view, whether you'll be drawing your right side view or left side view. Okay, and depending on that, you have to draw this front view and top view of a point A. Okay, either you have to draw it on right hand side or left hand side. For drawing left hand side view, you have to draw this over here. Okay, if you're drawing right side view that is on left profile plane, you have to draw it here as I've shown here. Okay, listen to me first. Okay, then you can draw it by yourself. So what is meter method? So in meter method, okay, in order to draw the side view, so side view will be in line with the front view, that is A dash. Okay, as you have A dash and A, that is A dash and A, that is front view and top view in line, you know, vertically. Same way, your side view will be in line with your front view horizontally. Okay. So what is meter method? How will you obtain the side view of a point A? Okay. So in order to obtain the side view of a point A using meter method, So you know that side view will somewhere it will be here. Okay. Now from the intersection of x1 y1 line and xy line, okay, you have to draw a line, okay, a line which is at an angle 45 degrees, which is at an angle 45 degrees, which is at an angle 45 degrees. Okay. Once you draw this, next step is from this top view of a point A, you have to draw a horizontal line till this 45-degree line. Okay, till this 45-degree line, and you have to show this direction of projection. Okay, direction of projection. You have taken it from right to left. You have drawn a line from right to left. Then from this point, you draw a vertical projection line. You just draw a vertical projection line. Okay. Then from this A dash, okay, front view, you draw one more horizontal projection line. So this projection line and this projection line will intersect somewhere here. Will intersect somewhere here. Okay, that is your side view A double dash. Okay, A double dash. And these are the directions of projections. So this is your drawing the side view using Mercury method. Draw first 45-degree line, okay, from the intersection of x1 y1 line. Then draw the projection lines both from front view as well as top view. So from the top view, I will draw the projection line till this 45-degree line, horizontal projection line to the left, and then upwards. Then from this A dash, draw horizontal projection line. This line and this line will intersect. That intersection point will be nothing but your side view A double dash. A double dash. So this is your drawing the side view using Mercury method. Got it? Got it. This is Mercury method. Got it, everyone? Any doubts here in Mercury method? Yes? You can put a message in the chat box, or else you can ask me. Make it fast. Make it fast. Understood? Mercury method?
Yes, sir.
Okay, fine. Okay. Just let me know whether you understood or not. Okay. Now let me erase this. Okay. Let me erase this. I'll draw using the other method. That is arc method. Okay, that is arc method. That is the arc method. Okay. Again, first I'll draw a reference line. Okay. X1 and Y1. X1 and Y1. Now, what I'll do is from this top view, okay, that is E, I'll just draw an horizontal line till this reference line X1, Y1. Now, with this as a center, with this intersection between x1 y1 line and xy line as a center, and this as your radius, okay, I'll just draw an arc here like this. I cannot draw it arc properly. Just you have to draw an arc like this. Okay, you draw an arc like this and show the directions. Okay, show the directions. And next, You have to take this vertically upwards and this horizontally to the left, and intersection of this two will give you side view, which is denoted by a double dash. A double dash. So this is your arc method. Okay. So instead of drawing a 45-degree line, okay, you have drawn an arc in order to obtain the side view. Okay, in order to obtain the side view. Got it? This is your arc method, and you have to show the directions of projections. How this is obtained? Okay, with the help of direction of projections. First, this to left till this x1 line. Then from here, this as center. Okay, draw an arc. Okay, draw an arc till here. Then from here, draw a vertical projection line and draw this horizontal projection line. This will intersect here. That will be your side view A double dash. So this is your arc method. This is your arc method. Got it? This is how you draw side view. Okay. There are two methods. One is meter method. Other is arc method. Okay. Other is arc method. Got it? Understood?
Yes, sir.
Okay. We'll just go through this video. Go through the video. Okay. Just no need of sound. Okay. Just here. Just go through the video. Okay. Here, in order to draw the side view of a point, Metroline method and arc method. Okay. So what is Metroline method? It first takes a problem. Let's have taken the same problem. Consider a point 30 mm, both HP and 20 mm in front of vertical plane. Okay. He'll draw the front view, side view, and right hand side view. See, this is your roll and draw scale. Okay. This is your roll and draw scale. So first he draws a reference line X and Y. Okay. Then he'll draw the front view at a distance 30 mm above XY line A dash. Then top view 20 mm below XY line denoted by A. Now, in order to draw the side view, you can see side view will come here. Okay, side view will come here. He'll draw one more reference line. So x1, y1. Okay, x1, y1. Now draw a 45-degree line from the intersection of x1, y1 line. Okay. Then draw a horizontal projection line till this 45-degree line, and from here one more vertical projection line, and from A dash your horizontal projection line. These two lines will intersect. That will give you side view of point A denoted by A double dash. This is your Metroline method. Okay. The same problem he'll do it by using arc method. Okay. Same, everything you have to draw. Now here is drawing the line here up till x1 level line. Okay. Then you can see here with this as the center and this as the radius, you'll draw an arc. Okay. You'll draw an arc till this xy line, and from there you draw a vertical line. Okay. And from here you draw a horizontal line, and that will intersect. That will give you side view using arc method. Is it clear? Is it clear how to draw the side view? How to draw this in the software, I'll tell you in the next class. It's almost time is up now. I'll tell you in the next class. Got it? It's better you complete this in your book. Okay? Complete this in your book. Any doubts you can ask. Any doubts you can ask. Is it clear to everyone how to draw the side view? So in the next class,